Hello, welcome to this presentation. I'm Leonardo Benitez and I will talk about how to manage in the milk production industry energy consumption and animal welfare both in a single integrated management system, taking advantage of technologies like machine learning, Internet of Things and computer vision. When talking about milk production, several variables must be considered. For instance, electricity consumption, water consumption, maintenance cost, the health of the animals, and each of those items can be further divided. For instance, when talking about health, we can talk about the welfare of the animal that will impact its production and the quality of the milk, the food intake, the disease it have. So all those variables can, of course, we can look individually to each one of them, but it will be very good if we can, in a single management system, have an overview and see all the indicators related to the production, so have an overview of the whole system. And there are some examples in the literature. For example, in the Milk from this paper, they managed electricity and water in a single system and achieved very significant savings, 20% in energy and 30% in water. There are other examples. For instance, from this paper here, they developed a control system to the growth of poultry, because if the poultry grows too fast, the animal will have health problems, and if the animal grows too slowly, we'll have an osseous capacity in our system. So controlling the food intake of the animal, we can make it follow an ideal growth trajectory. And there are other examples, not necessarily integrated, so looking into specific problems. For instance, we can detect health problems in the animals, analyzing the gait of the cow or other factors like the body temperature. We can analyze how the animals are interacting with each other, if they are being aggressive, because this will, if they are being aggressive with each other, because this will impact the happiness, the welfare of the animal, and that will directly impact the milk quality and milk production. And in this type of system, there are two technologies that are commonly used: Internet of Things and machine learning. So I will briefly explain about them. Internet of Things is a set of several technologies. Internet of Things is a set of several technologies that have the purpose of developing a collection of physical devices, of real things that are connected to the internet, collecting data, sending data, and communicating with each other. And this idea can be applied to several fields. For instance, personalized healthcare, smart cities, smart agriculture. So we will have smart devices communicating with each other to achieve real-time monitoring, control, and analysis of our problem. Another commonly used technology is machine learning, that is a subfield of artificial intelligence. Artificial intelligence is basically to perform computationally anything that is normally attributed to humans. For instance, interpreting a text, interpreting an image, reasoning about a problem. And specifically, machine learning aims to build artificial intelligence models using data. So using previous instances of our problem to build a model. And one specific application of machine learning is computer vision. That means that aims to extract some high-level understanding, some high-level perception from images or videos, for instance, to understand what is happening, to recognize what is happening in the video. And to build this type of system, we can use several techniques, for instance, artificial neural networks, decision trees, support vector machines, among several others. But the idea of all these models, of all these techniques, will be to take data and to take the ideal response to this situation, so to have a label to this situation, and from this historical data to create rules to model a function that will map from data to the answers in the future. So it will be a predictive model. And the objective of this paper is to present an initial conception, an initial vision of how we can manage the milk production in a single integrated management system. And that is challenging because the milk production involves several different variables. Some of them are highly objective, like water consumption that can be easily measured. Some of them are highly subjective, like the welfare of the animal, its behavior, how it is feeling, and how will this impact the quality of the milk. Some of them are individual, like the disease of an animal. Some of them are collective, like the maintenance of the whole barn. So there is a myriad of factors that impact the milk production, and it's challenging to see them together and to merge them in a single system, to merge the monitoring and the analysis of them in a single system. And we all began this project merging two existing projects. Project PGEM, under development in the Smart Grid Research Lab in the Federal Institute of Santa Catarina, Brazil, and the Barn 4.0 under development in Smart Research Unit in Heim University of Applied Sciences, Finland. PGEM means Energy Management Platform, Energy Management Portal. And why did we choose these two specific projects? They are complementary in how they can contribute to this integrated system. The PGEM project is related to energy efficiency, that is a very objective variable, and the Barn 4.0 is related to animal behavior, monitoring and analysis of animal behavior. That's a highly subjective variable, and we can analyze both for individual animals and for the whole aggregation. And also the expertises of the two laboratories are different. So LabSmart Research Lab in Smart Grids is focused on embedded systems and measure things and transmit things. So it's more about this initial part of the Internet of Things chain. And the Smart Research Unit is focused on cloud computing, machine learning, developing services, digital services with these ideas. So while one laboratory have more this part of the chain, the other have more this end part of the chain. So they are complementary both in what they measure and in their expertises. And I will begin briefly describing those two individual projects. PGEM project aims to bring detailed information about energy consumption of public institutions. The system is installed in several campuses of the Federal Institute of Santa Catarina, IFSC, and in three buildings of the Ministry's Esplanade, that is the Brazilian Government Executive Power Headquarters. And the ultimate goal is to bring more understanding on the energy use and how we can manage it. And it brings to the user real-time visualization tools of the electrical consumption and also analytic tools. I have to apologize because the images are in Portuguese. This paper was originally published in Portuguese, so I'm using the original images from the paper, but I think that there is no problem. Here we can see two screens of the system. So this is the load curve of the Florianopolis campuses in one specific day. We have here about 2 years, I think, of historical data from Florianopolis campus and from other campuses as well. And we can see the consumption every day, aggregated informations. We can set up goals of consumptions, line bases. We can have detailed informations of this consumption and several other features. This website is publicly available under this address here. The system also have a machine learning model to predict the energy consumption. With it we can do consumption forecast, of course, but also to generate alerts about when the actual consumption is too high, given the current conditions of weather, of how many persons there are in the building and other variables. So we can generate alerts, we can analyze the impact, we can measure in a very objective way the impacts of energy efficiency actions. So if you train a model with data before you take energy efficiency actions like changing equipment for more efficient ones, or having different management practices, if we train a model with data from before those actions and evaluate after these actions using that same model that will be predicting how you would consume if you did not take those actions, you can precisely evaluate the impact, how much did you save it in energy. And here we can see the model, the predictive model. This is the evaluation, the predictive values versus the real values. This was explained in a previous paper, so I will not talk too much about it, but we have predictive models to help to analyze these informations here. The BAR 4.0 project automates the monitoring and analysis of the animals in the milk production industry, and we use video cameras, several environmental sensors, and physical-chemical analysis of the milk to gather information about the production. We have sensors installed in several parts of the barn, and we have video cameras from which we can analyze, for instance, the behavior of the cow. So from this image, from this camera here, we can take this image and we can run it through a neural network that we developed to analyze what is happening in the image. So this is the output of our neural network, and we can see here that with 59% of confidence the neural network is predicting that in this image there is class number 5 happening, and class number 5 we previously defined it as meaning drinking water. So the neural network is predicting that there is a cow drinking water in this image, and yes, we can see that in fact there is a cow drinking water in this image. And the neural network that do this prediction is based on the VGG16 architecture. Here, that is our neural network that we developed and trained. Here we can see natural language interpretation that is generated by our system, and natural language interpretation of this result right here. And as we said, we also analyze other variables, for instance temperature and milk production. Those two variables, there is plenty of literature about how they are related, showing that yes, indeed the temperature impacts the milk production. I just put some titles and references here, and we are also analyzing those two variables among others, for instance CO2, humidity, pressure. So I have briefly described those two individual projects, and now how we can integrate them in a single integrated management system. Electricity represents an important amount of the total production budget, 7% in the US in 2002, that is more than 1.2 billion American dollars, and from this amount, most part is dedicated to heating, ventilation, and lighting. And as we just saw, the temperature is one of the variables that affects the milk production. So a system that optimizes the levels of heating, ventilation, and lighting, taking into account both the energy expenditure and the thermal stress of the animal, can greatly benefit the milk production and the dairy industry. And this can be automatically analyzed for different breeds of cows for different countries, because we are analyzing in real time the behavior and the consumption, so it will not be just a fixed level of heating and ventilation. We can adapt it to different breeds of cows, to different weathers, to different situations. This way the same system can be useful both to a barn in Brazil and to a barn in Finland, as well as to a barn in the US. And the same reasoning can be applied to other examples. For instance, how often do we clean the barn? So how much water we will consume to improve the health of the animals? How much do you feed the animal and the nutritional value of the food? How often and how you do maintenance of the equipments and the barn and everything. So analyze the complex system that is the milk production. Everything integrated in a single system can be of benefit to the milk industry. And what we see that to really add value to the producer, to the farmer, this system should be extended to both the plantation field, so from where comes the food to the cow, to the final consumer, so to both ends of the chain. And what we aim to do is a system that analyzes the production of the food, of the hay. And this is an image from another project, a third project in the Ham University of Applied Sciences, called DigiBio, that aims to monitor the grow and the logistic transportation of the hay and the hay bales that will feed the cows. And this is an image from the barn, and this is an image from the Pegen system. So analyzing the whole chain together, we can understand how we are feeding the cow, how it is growing, how it is feeding, how it is being affected by other variables, how it is producing the milk, how this milk is being processed. And here, when we think about processing this milk, we also aim to integrate it with another project that is under development in Federal Institute of Santa Catarina, that is aimed to energy efficiency in industrial processes, until we get to the consumer's table. So we can analyze the whole system together, and to do this, to really bring to the farmer an easy way of analyzing, we see that it should be done using a web platform or a mobile application that will bring real-time information about the production in a very simple, everything together, so that the farmer will be able to take better decisions and do a better use of its resources. And to do a system like that, both Internet of Things and machine learning are very central to be able to put everything together, so to be able to analyze these variables together. And this framework that we are presenting here have a very low implementation cost. This is something that we are taking into account since the beginning of both projects. And what we can do after we implement the system. Well, after implemented for dairy cows, it can easily be applied to slaughter cows, so to produce meat, as well as to other animals like pigs and poultry. The same technologies and the same very idea of an integrated management system can be expanded to other industries, because we are using very flexible technologies like computer vision that we can easily train to another task, train the neural network to perform another task, to recognize a different situation, a different behavior. And other projects being developed in very modular components. So we believe that this effort to integrate those two systems will be very fruitful, and in future works we pretend to publish real results with this integration. And here are the main references to this presentation. I hope you like it. That's all. We are at disposition. Here are our contact informations, and we'll have some time now for questions and answers. Thank you very much. Muito obrigado. Kitos Palion.